Good day, students. Welcome to Mathgotserved.com. And this clip, we're going to be going over section 1.7a of our virtual geometry text on the basics of geometry. We're going to be looking at how to identify angle relationship, part one of a three-part series. We're going to be taking a look at problems such as one that's presented here. If you have a pair of angles like this, can you name the relationship? Don't forget, there are 9 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate that you've mastered the contents of this presentation. To get us started, we're going to be taking a look at our 9 angle pair relationship definitions that we're going to be using to guide our problem solving process. All right, so the first one is adjacent angles. Now, what are adjacent angles? The definition is as follows. Adjacent angles are angles that share a common side, vertex, and no interior points. So if the two angles share no interior points, that basically means that the angles do not overlap. All right, so we have a representation of adjacent angles in the diagram below. So you can see angle 1 and 2, they are adjacent angles. Another word for adjacent is side to side. And if you notice that these two angles do not overlap or share any interior points in common. Okay, and then if you want to say this verbally, you just basically say angles 1 and 2 are adjacent angles. Now this is a presentation that you can gain access to on our website mathgotserved.com. On the geometry section, you can gain access to this slideshow that I'm going over right now. The next angle pair relationship definition that you need to know is linear pair. Now, what are linear pairs? The definition is as follows. A linear pair are two adjacent angles. We talked about adjacent angles in the first definition. Angles next to each other. They share a common vertex and a common side with no points, with no overlaps, no common interior points. Okay, so a linear pair are two adjacent angles that form a straight line. All right, so certain things to keep in mind concerning straight line is angles that form a straight line are supplementary or they add up to 180 degrees. Another point to note concerning linear pairs is that the non-common sides of a linear pair form opposite rays. Now, what does that mean? Well, let's take a look at the representations that we have down here. In the diagram below, you can see angles 1 and 2 are a linear pair. They add up to 180, and if you notice, the non-common sides of angle 2 and angle 1 are opposite rays. All right, when opposite rays share a common point of origin, it forms a perfectly straight line. Alrighty, so angles 1 and 2 are a linear pair, and a relationship between these two angles as indicated here is that the measure of angle 1 plus the measure of angle 2 is 180 degrees. Remember, linear pair angles are always supplementary or add up to 180 degrees. So this is formula 2 that can be found on the geometry section of Mathgotserved.com. All right, the next definition are complementary angles. Now, what are complementary angles? Well, the definition is as follows. Two angles are complementary if and only if they add up to 90 degrees. Okay, so you need to remember the difference between complementary and supplementary. Complementary is 90 degrees, add up to 90 degrees, and supplementary adds up to 180, like the linear pair definition that we went over in the previous formula. Complementary angles can be adjacent or non-adjacent. Linear pairs are always adjacent, but complementary angles are non-adjacent. How do they look like? Well, let's take a look at the representations below. We have a geometric representation here. Two representations of complementary angles. The first set, 1 and 2, these are non-adjacent. It means that they do not share any sides in common. And then over here, the second representation is a case where they are adjacent next to each other. They share a side in common. A relationship to keep in mind between complementary angles is that they add up to 90 degrees as illustrated in this equation right here. Measure of angle 1 plus measure of angle 2 is equal to 90 degrees. All right, the next definition you want to keep in mind are vertical angles. Okay, what are vertical angles? Let's take a look at the definition. Vertical angles are opposite angles formed by two intersecting lines. Remember that vertical angles are always equal. We have a representation of vertical angles below. Look at the diagram. You can see that these two intersecting lines create two angles, one on top and one on the bottom, that are vertical angles. They're always opposite each other, formed by two intersecting lines. Verbal representation, you can say angles 1 and angles 2 are vertical angles. Now, what's the relationship between these two angles? We stated it earlier that vertical angles are always equal. So the measure of angle 1 is equal to the measure of angle 2. All right, the next definition are corresponding angles. Now, what are corresponding angles? Well, a pair of angles that occupy the same relative position in a cluster of two angles are corresponding angles. And if you take a look at the diagram we have right here, we have a geometric representation of corresponding angles. Now, think about this point that is a result of the intersection of L1 and the transversal. And this other point has an intersection of L2 and the same transversal. So on the first line, L1, we have a cluster of 4 angles here. And in L2, you have a cluster of 4 angles here. All right? So you can think about it as quadrants. So you can say 1, 2, 3, 4. And over here, you have 1, 2, 3, 4. So if you notice, angle 1 is occupying the upper left quadrant in the first cluster, and angle 2 is occupying the upper left quadrant in the second cluster. So they occupy the same relative position in these two clusters of angles, and that is basically what corresponding angles mean. All right? So angles 1 and angles 2 are corresponding angles. Now, if L2 and L1 are parallel lines, then it follows that angle 1 and angle 2 are congruent. All right? So remember, when parallel lines are cut by a transversal, corresponding angles are always congruent. All right, the next definition are alternate interior angles. So basically the name alternate and interior can easily help you identify what alternate interior angles are. So the definition is as follows. Angles on opposite sides of a transversal in the region between basically means in the interior of two lines cut by the transversal. Those are alternate interior angles. Okay? So if you take a look at this diagram right here, we have two alternate interior angles. Now these two lines right here, in between them represents the interior. All right? And for this transversal, above it and below it are the opposite sides. So you notice that the angles, one is above, one is below. That means that they're on opposite sides or alternate sides of the transversal. Now, since they're in between the two lines, they're in the interior. So when you combine opposite and interior together, or in between, you have your alternate interior angles. Now, if L1 and L2 are parallel, then it follows that the measure of angle 1 and angle 2 are congruent. Okay? So when parallel lines are cut by a transversal, alternate interior angles are always congruent. All right, the next angle pair definition that you need to know are alternate exterior angles. Okay, similar to what we just talked about concerning alternate interior angles. Now the definition of alternate exterior angles are as follows. Angles on the opposite sides, alternate sides of a transversal on the region outside or in the exterior of two lines cut by the transversal. That's what alternate exterior angles mean. if you examine the name word by word, you should be able to identify it. Alternate means opposite sides of the transversal. Exterior means that you're outside the region bounded by the lines. So let's take a look at the geometrical representation we have here. Angles 1 and 2 are alternate exterior angles. Okay, so this transversal above it and below it can be thought of as the opposite sides of the transversal, or the alternate sides. And the region outside that's not bounded between these two lines are the exterior. So this is the exterior and this is the exterior. Okay, so since the angles are on the exterior, on the outside, and on different sides of the transversal, or the alternate sides of the transversal, they are alternate exterior angles. Now, what kind of relationship do they have? If L1 and L2 are parallel, then alternate exterior angles 1 and 2 are congruent. Okay? So the general rule again is, if you have parallel lines cut by a transversal, alternate exterior angles are congruent. All right, the next definition that you need to know are same side interior angles. Okay, what are same side interior angles? Well, angles on the same side of the transversal between lines cut by the transversal are same side interior angles. Let's take a look at the geometric representation given here in this diagram. Now, if you think about same side interior and alternate interior, same side is basically the opposite of alternate. Okay, alternate means you're on different sides of the transversal. Same side means that you're on the same side of the transversal. All right, so if you look at the diagram, this line right here is the transversal. It's the one that travels across these two lines. If you notice, angle 1 and angle 2 are on the upper side. They are on the same side of the transversal. Now, how about this interior component? How do we know that these two angles are in the interior? Well, it is because they are between these two lines. So if you're between these two lines, the angle between these two lines, this entire region can be considered as the interior. All right, so you put those two together, same side and interior, you have same side interior angles. Okay, now what's the relationship, a special relationship here? Now, if angles 1 and 2, if line 1 and 2 are parallel, then angles 1 and 2 are going to be supplementary. Okay, if L1 and L2 are parallel, then angle 1 and 2 are supplementary. Do you remember what supplementary angles mean? Supplementary angles are angles that add up to 180. Okay, so we have the relationship here, the symbolic representation. If L1 and L2 are parallel, then the measure of angle 1 plus the measure of angle 2 is equal to 180, or they are supplementary. Went over to use. Okay, instructions are for us to identify the relationship between the angles that were given as adjacent, linear pair, complementary, vertical, corresponding, alternate interior, alternate exterior, same side interior, or same side exterior angles. Okay, all right, so let's take a look at question number 1. What is the relationship between angle X and angle Y? If you notice, these two angles form a straight line. All right, so what do you think they are? These two angles they form a linear pair. All right, so angles 1 and X and Y form a linear pair. Remember, linear pair angles are adjacent angles that form a straight line or 180 degrees. Okay, so let's take a look at number 2. There's a little detail here. Let's put a box. Okay, so what's the angular relationship between these two angles right here? Angle X and angle Y. This box that I put right here but just basically means that this angle measures 90 degrees. Okay, so if these two angles measure 90 degrees, what can we classify them as? These are complementary angles. They are complementary. They are not also only complementary, we can also classify them as adjacent angles. Remember, not all complementary angles are adjacent. So these angles are complementary and they are adjacent. All right, let's take a look at question 3. Now, how would you describe the relationship? Now, these two angles are next to each other, okay? But there's no mark here indicating that it's a 90-degree angle. So we know for certainty that they're next to each other. They do not share any interior points in common, so they are adjacent angles. Adjacent angles. Remember that word adjacent means next to each other. All right, so let's take a look at this right here, question number 4. We have a transversal on these two lines. And if you look at the cluster of angles here, so this is cluster 1 and this is cluster 2, what you notice is that angle X and angle Y occupy the same relative position, namely the upper left. So in this first cluster, let's call this cluster 1. In this first cluster, angle X occupies the upper left quadrant. And in this second cluster right here, angle Y occupies the upper left quadrant. All right, so if two angles occupy the same relative position in a cluster of angles, guess what they are called? They are called corresponding angles. All right, so the relationship between these they are corresponding angles for problem number 4. Okay, let's take a look at number 5. So for number 5, what you notice is that obviously they're not at the same relative position, so they're not corresponding. But let's see what's going on here. So this is our transversal right here. Okay, so if this is our transversal, we have the left side, left, and the right. All right, these can be considered as alternate or opposite sides. Okay, so first thing to note is that the angles are on opposite sides, they're on alternate sides. Now, are they in the interior or exterior of the two lines? This region right here is called the interior. Why? Because it's between the two lines. Okay, and then if you go above or below the regions, you have your exterior. So over here is exterior, and over here is exterior. So what do you notice about angle Y and X? They are not only are they on alternate or opposite sides, they are also on the exterior. So if you put those two words together, that basically tells us what we're looking for here. Angles X and Y are alternate exterior angles. Alternate exterior. All right, let's look at number 6. Number 6, we can see that they do not occupy the same relative position, so they are not corresponding. This is in the upper left, this is in the lower left. And they're not alternate because they're on the same side, okay? So what do you think these are called? Well, they are on the exterior for sure, because this is the interior right here. They're not in the interior. If you're not the interior and the exterior, they're the exterior. And they're both on the left side of the transversal. They are not on the alternate sides like in number 5. The opposite of alternate is same side. All right? So if they are on the exterior on the same side, these two angles are known as same side exterior angles. Okay? So that's the answer for question number 6. They're same side exterior angles. All right, let's take a look at question 7. Now, question 7, if you look at these two angles right here, you have two intersecting lines that create these two angles that are opposite each other. Now, what do you call that? An angle formed by two opposite angles formed by two intersecting lines. These two angles are known as vertical angles. Okay, and a side point is that vertical angles are always congruent. Okay, all right, number 8, let's look at this. So we have a cluster of angles here. and a cluster of angles here. So we have cluster 1, let's call this cluster 1 and call this cluster 2. We can clearly see that these two angles do not occupy the same relative position, so they're not corresponding. Okay, so throw that out. But we know one thing for sure though. We know that they're in between the two lines. This region right here is the interior. Okay, they're in between. So we have that down. And this, let's look at the transversal. Okay, so you have a transversal here. This is the left side and this is the right side. The angles are on alternate sides of the transversal, or different sides of the transversal. So if we put the two words together, alternate and interior, you will know exactly what the relationship between these two angles are. Angles X and Y are alternate interior angles. All right, let's take a look at one more, and then we're going to give you 9 problems to try out to demonstrate that you've mastered what's going on in this presentation. Okay, so let's look at angle X and Y in this particular example right here. Now, if you take a look at these two clusters, let's say this is cluster 1 and cluster 2, we can see that they do not occupy the same relative position. Okay, so we know that they're not corresponding. What do we know about these two angles though? First things first, we know that they are in between the two lines. Okay, they are in between the two lines, which means they're what? They are in the interior. We talked about this before. If you're not in between the interior, then you're in the exterior. Okay, so they're in the interior. And considering this transversal right here, the transversal is a line that cuts these two lines. This is, let's call this the upper side of the transversal and the lower side of the transversal. What do you notice? They are on the same side of the transversal. So they are not alternate, they are same side. So if you put this word and this word together, you know exactly what the relationship is between these two angles. Angles X and Y are same side interior angles. Okay, same side interior angles. So that's the relationship between angles X and Y. All right, it's your turn to do some practice problems. Okay, so at this time, we'd like you to try out these 9 problems. Instructions are the same as the sample problems we just did. You have to identify the relationship between the given angles, identify them as adjacent, linear pair, complementary, vertical, corresponding, alternate interior, alternate exterior, same side interior, or same side exterior. Okay, so go ahead and pause this video presentation at this time. Try out these 9 problems. When you're done, click on the playback button and we're going to show you what the correct answers are. Alrighty, welcome back. So hopefully you had a chance to try out these problems. Oh, there's something that was missing here. For number 4, there's supposed to be a box right here to help you out with that. Sorry about that. Okay, so number 1. Number 1 is adjacent angles. These are adjacent. Number 2, these are vertical angles. Number 3, these are form a linear pair. Number 4, these are complementary. And they're also adjacent. Okay, I didn't put the box there earlier, so it's hard to know that it's complementary. So with the box there, you know that it's complementary. All right, and number 5, these are alternate interior angles. Alternate interior. Number 6, these are same side interior. Number 7, these are alternate exterior. Number 8, these are same side exterior. And then number 9, these are corresponding angles. Okay, so how well did you do in these 9 practice problems? Let us know in the comment section below what your score was. Now, if there are any questions or clarifications that you want on any of these practice problems, the problems we did, or any of the vocab problems that we went over, just specify it in the comment section below and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of the basics of geometry, do give us a thumbs up or a like. Your positive feedback is extremely important to us. Do not forget, you can gain access to all the vocab definitions that we went over at the beginning of this presentation at mathgotserved.com/geometry, or just look at the link in the description below. And don't forget to subscribe to our channel. We're going to be uploading tons of great geometry tutorials to help you do well in your geometry class. As indicated earlier, if you have any questions or comments or special requests, just place it in the comments section below and we will be more than glad to support you. Thanks again for watching and have a wonderful day. Goodbye.